I'm Peter Carter. I'm making a pretty big video. This is practically my biggest project. I've been doing this with my presentations for the Climate Emergency Institute. The big image with the many data sets on atmospheric greenhouse gas pollution, indicators and direct effects. This is my 2019 update of my AGU and EGU presentations. The presentations, of course, are to provide the evidence, and the evidence has been overwhelming for several years, that we are in a global climate planetary emergency. And the last of the presentations that I put together demonstrated that we are trending towards biosphere collapse. And that's how bad things are today. I'm making the video as this overwhelming proof that there is an urgent, most urgent, ethical, economic, energy, food, and democratic requirement for total conversion or transformation. The IPCC 1.5 degrees C most recent report of October 2018, you may remember because the media covered this well. It's an excellent report. Scientists did a great job on this one. To stabilize climate at 1.5 degrees C will require changes at all levels of society. The response, which the IPCC has been telling us for a number of years now, has to be global greenhouse gas, carbon dioxide, of course, especially, decline now. The now has to be immediate time frame, according to all the scientific research papers and all the other intergovernmental reports like United Nations Environment Program, etc. They show that emissions, global emissions, have to decline by 2020 at the very latest. This we are readily able to do. This evidence supports the excellent work of, for example, the climate mobilization in the United States, and also the recent accurate assessment of the situation the movement started in the UK and now spreading internationally, called Extinction Rebellion. This evidence shows that protest is mandatory. The people that are getting out on the streets and on the lands and the pipelines and protesting, these are in no way, shape or form the criminals. These are the true citizens. The governments and the government's legal apparatus, which is censoring and charging these protests, these governments are the criminals. And that is because this is the crime of all time. Continuing to pollute the atmosphere as well as the oceans with CO2, with atmospheric greenhouse gases, is the crime of all time. And there's no crime worse. There never has been a crime worse than the governments, and this applies to almost all the world governments, continuing with fossil fuel subsidies. This is also support overwhelming evidence for our children's trust. The legal challenge, which has started in 2011 in the United States, the case started in Oregon, and the case is based on the public trust doctrine and is an example of atmospheric litigation, because children, young people, they are going to be severely affected by global climate disruption. That has already been determined by the unprecedented concentrations of greenhouse gases in the atmosphere, particularly, of course, carbon dioxide. Carbon dioxide is at the highest level that it's been in the past 3 to 5 million years. The government of the United States, of course, particularly under the Trump Republican administration, is totally in the wrong, and the children, the young people, are in the right, and they are having their rights most severely abused. This is a terrible, atrocious crime. It's actually an ultimate evil, is what it is, because the planet, the climate, the forests, the Arctic and the oceans are being trashed, literally. The biosphere is tending rapidly towards collapse. So finally, I give a plug for the book that I co-authored with Elizabeth Woodworth that was published nearly a year ago now, called Unprecedented Crime, Climate Science Denial and Game Changers for Survival. The evidence in this book is really still up to date because we took the scientific evidence right up to 2018, immediately prior to the publication. So here is the big Earth emergency data picture, all of these data sets, and they are up to February of 2019. Most of them, the others are up to the latest publication from the science, and they are all getting worse faster. I'm going to start with, I've sectioned them off to some extent this time around. I've got greenhouse gases in this quadrant, and I've got warming temperature increase in this quadrant. Here I have the Arctic, and here at the bottom, I have the oceans along here. We're going to start actually in the upper right here, and we're going to start with life. We're going to start with species and life on our planet Earth. So the science is definite that we are in the sixth mass extinction of species. This is a 2015 scientific study. There was another one by the Stanford team a couple of years later, which had the title of Biological Annihilation of Vertebrate Species. This particular paper showed the acceleration, the rapid acceleration of this sixth mass extinction, which of course is caused by humanity, but only a specific, small, very recent aspect of humanity, which applies to the industrialized era. So this goes back to 1600, and there is increase in extinction rate from 1700, but then things really take off in the most terrible accelerating manner. This is the cumulative extinctions by percent of species assessed by the IUCN, which is the International Union for the Conservation of Nature. These species at the top here, mammals and birds, here vertebrates in general, here fish and other vertebrates. This dotted line along the bottom here is the background rate over ages of time. Species naturally die out. The rate of extinction today is estimated to be at least 1,000 times that background rate. Now, it's well known that the highest rate of extinctions is occurring at the highest regions of biodiversity, the tropical rainforests. But species extinctions and disappearance of life is also happening in the oceans, and reduction in life and increased species extinction is also happening in other regions of the world, particularly where there's high biodiversity, for example, coastlines and estuaries. But in general, there's a very great increase in the rate of extinctions. This chart shows the impact of global climate disruption on ecosystems and species from the IPCC 2007. And what it shows is that when we get much above 2.5 degrees C, up to 50% more species, that's more than the sixth mass extinction ongoing, are committed to extinction. But at 1.5 degrees C, up to 31% more species are committed to extinction. And that takes me to this most recent horrific scientific finding, which is that there is a mass insect die-off. Many of us might have assumed, if not hoped, that insects would escape or be able to adapt to the destruction and degradation of natural ecosystems and habitats, but that is absolutely not the case. This research here finds that there's a 40% decline in insects in general, and that is over the past recent decades. And so that is truly. These are the factors in the global insect decline in the paper, and global warming is included. So global climate disruption is already impacting the survival of insects and is 5% of the factors. Food production, if we take agriculture, pesticides, and deforestation, is responsible for half of the catastrophic decline in global insect life. Although the world has been well aware of tropical deforestation for 3 decades, we have not made progress towards stopping this. Tropical rainforest deforestation is destruction of habitat on a massive scale, and everyone knows that's the major cause of species loss, the current 6th mass extinction of species. This is an assessment of monthly deforestation in the Amazon from 2009 to 2018. And it shows that for the last year, 2018, deforestation is way higher than it was in 2009, and in the past couple of years is increasing at a very rapid rate. Deforestation, of course, is an emitter of carbon dioxide and accounts for up to 10% of carbon dioxide emissions. 2018 was a record year for deforestation in the Brazilian Amazon rainforest. About 7,900 square kilometers, or over 3,000 square miles of forest were cleared last year, and that is a 13.7% jump from the same period last year. It amounts to an area of deforestation equivalent to 987,500 football fields and represents 1,850,000,000 trees removed. The World Resources Institute tracks tropical tree cover loss, or the canopy. This is the 2018 report of tropical tree cover loss running from 2001 to 2017, and this is clearly accelerating. Global climate disruption will further accelerate the already accelerating rate of extinction of the current and ongoing 6th mass extinction. This is a paper on that aspect. This is a paper on that aspect published in 2015. This is a paper published in 2018 that shows that the extinction rate, particularly with impact from climate change, will be far higher than present estimates. This paper, called Co-Extinctions, Annihilate Planetary Life During Extreme Environmental Change. What it says in the abstract is that climate change and human activity are dooming species at an unprecedented rate via a plethora of direct and indirect, often synergistic mechanisms. Among these, primary extinctions driven by environmental change could be just the tip of an enormous extinction iceberg. As our understanding of the importance of ecological interactions advances, it is becoming clearer how the disappearance of consumers, that's in the food chains, following the depletion of their resources, a process known as co-extinction, is more likely to be the major driver of biodiversity loss. As well as deforestation, deforestation due to the chainsaw, there's also increased tree mortality and increased forest dieback due to global climate disruption, global warming, climate change. And this was reported by the IPCC, the Intergovernmental Panel on Climate Change, in its last assessment, 2014, and the quote, and they had a map showing all the regions of the world affected, and the quote is there's increased tree mortality and forest dieback on all vegetated continents due to temperature and drought stress. So that brings us right back to the rate of extinction of species, because it was well established with a lot of publicity in the fourth 2007 IPCC assessment that global climate disruption would greatly further accelerate the already accelerating rate of species extinction. Forest dieback is a feedback to global warming climate disruption, because with increased carbon dioxide concentration, the forests have been greening up. They've had some increase in the growth, leafing, foliage, due to the carbon dioxide fertilization effect. But as it has been predicted and anticipated for decades that would only last for so long, and there would come a time when the global warming climate disruption would start to eat into that benefit to the forests, and the carbon sinking effect of the forests would fail and would switch to a carbon source, a huge, massive carbon feedback with extra carbon dioxide and extra global warming. There are indications from the research that this is already starting to take place. So from the top right corner, we're going to go to the top left corner here. And this is the cause, the driving primary root cause of global warming, global climate disruption, ocean acidification, ocean heating, and ocean deoxygenation. Because this is world GDP, and world GDP is fossil fueled. It's fossil fueled driven global production and consumption. It's driven by the multinational big banks, and in league, of course, with the big multinational fossil fuel corporations. This record of world GDP runs from 1960 up to 2017, and you can see the accelerating exponential growth of GDP. And so here we have fossil fuel carbon dioxide emissions, which of course follow the same rapid growth with a few little kinks on the way. This is the most recent record of fossil fuel carbon dioxide emissions. It's from the Global Carbon Project, published in December 2018. The Global Carbon Project is the authoritative source run by the world's experts of carbon dioxide, its emissions, the breakdown of emissions, and the changes to the carbon cycle, carbon sinks, etc. This axis here is carbon dioxide emissions in gigaton per year, and here the red spot is 2018. So 2018 was another record year for fossil fuel carbon dioxide emissions, but not only that, it was a record by a big jump. It jumped by 2.7%, which is a huge jump. Prior to that, also in 2017, there was an increase. See this temporary year or two decrease. That's from the very temporary global recession due to the multinational bank mortgage fiasco, and the following year, fossil fuel carbon dioxide emissions kicked right up again. The fossil fuel carbon dioxide emissions in 2018 were 37.1 gigatons. This represents an absolutely massive increase from 20 or so gigatons in 1990 up to nearly 40 gigatons in 2018. With record carbon dioxide emissions, of course, we have record atmospheric carbon dioxide concentrations. Before I go through some atmospheric carbon dioxide concentration graphs, it's important to establish very important context. This is the image on the data set, atmospheric CO2 is at an abrupt 3 to 5 million year high, accelerating at a rate with no past precedent. That's the World Meteorological Organization in 2017. So here is where that is from. The WMO Greenhouse Gas Bulletin, published October 2017, and the quotes are: the rate of increase of atmospheric CO2 over the past 70 years is nearly 100 times larger than at the end of the last ice age. As far as direct and proxy observations can tell, such abrupt changes in the atmospheric levels of CO2 have never before been seen, and those proxies go back 40 to 50 million years. So in the past 40 to 50 million years, there's been nothing like the rate of increase of atmospheric CO2 over the past 50 years. The current levels of CO2 correspond to the mid-Pliocene, that's 3 to 5 million years ago. This record of atmospheric carbon dioxide concentration clearly shows that it is rapidly accelerating. This is from the Scripps Institute of Oceanography, the Mauna Loa Observatory Monitoring Site. It runs from 1958 up to March of 2019. The trace shows the seasonally adjusted mean atmospheric CO2 concentration, which is currently at 411 parts per million of air. There's 410 and there's 400. This shows the same record from 2000 to March of 2019. It is at 411 parts per million, there's 410, and there's 400. And you'll see this pretty abrupt increase there. This shows atmospheric CO2 concentration, and again it's from the Mauna Loa monitoring site in Hawaii. This is the record that's kept by the NOAA. That's the U.S. National Oceanic and Atmospheric Administration. It runs from 1958 to March of 2019. The blue line there again is the seasonally adjusted mean CO2 at 411 parts per million, and the bright green sawtooth up and down, that's the monthly atmospheric carbon dioxide concentration. This level here is the level of 350 parts per million. Here is 300 parts per million. That's the 800,000 year ice core limit. It's never gone above 300 ppm. And this is the pre-industrial concentration of 278 parts per million. This is global atmospheric carbon dioxide concentration, globally averaged from all the sites around the world. It's from the NOAA again, and it runs from 1980 to March 2019. It also shows an accelerating trend. This is that same record of global atmospheric carbon dioxide concentration from the NOAA, but it's taken just from 2010 up to March 2019. And even over this very short period of time, it's obvious that the atmospheric CO2 globally is accelerating. I've noted 350 parts per million down there. This is from Scripps Institute, and it shows atmospheric carbon dioxide concentration over the past 10,000 years up to March 2019, which is here at 411 parts per million. This shows a 350 ppm there, a 300 there, the 800,000 year ice core limit, and 278 ppm pre-industrial. And with industrialization, you can see that CO2 literally just shoots up, and see how much higher it is than the past 10,000 years. Consider then that when the atmospheric CO2 record was started in 1958, the World Meteorological Organization has told us that the rate of atmospheric CO2 increase was unprecedented. And then consider that it has been accelerating, getting faster and faster ever since on top of that. And today, its rate of increase has never been as fast. It's accelerating faster than ever. We now turn to the other greenhouse gases, methane and nitrous oxide. And here we have emissions, methane in blue at the top here and nitrous oxide in the brown. This is the 2018 last annual report of the Netherlands Environmental Agency, their PBL report on CO2 and greenhouse gases. These emissions are in gigatons again, gigatons of carbon dioxide equivalent, so the methane is just converted to an equivalent of amount of carbon dioxide, giving the same amount of heating effect, and the same applies to the nitrous oxide. So from 1990 emissions, they were pretty flat. But after 2000, they started increasing again, and they've been increasing rapidly ever since. Nitrous oxide has been increasing steadily, actually also rapidly, since certainly 2000 here. So here we come to atmospheric methane and atmospheric nitrous oxide concentrations. Here are the other two main greenhouse gases, methane and nitrous oxide. These atmospheric concentrations are both up to date, February 2019. They are both measured in parts per billion, in contrast to CO2, that's measured in parts per million. So for methane, there's 1900 ppb, 1800, 1700. The record for methane starts at 1984. It doesn't go as far back as CO2. And this is from NOAA, the Mauna Loa, awful level of 1,870 parts per billion. And I say that is awful because the 800,000-year ice core limit of methane in the atmosphere is 800 parts per billion, and we're at 1,870. So this is nitrous oxide. Nitrous oxide measurement started a little bit later, 1988, and this is February 2019, measured in parts per billion, 315, 325, 335. The 800,000-year ice core limit of nitrous oxide is 300 parts per billion, and now it is over 330 parts per billion. And as you see, it's been increasing steadily and rapidly. Continuing with atmospheric concentrations, the greenhouse gases, this combination here of carbon dioxide, methane, and nitrous oxide, which gives us an overview of the three main greenhouse gas concentrations. This runs from 1750 to pre-industrial. This is the greenhouse gas concentrations: carbon dioxide top, methane bottom, nitrous oxide. Carbon dioxide parts per million up to 400 parts per million right there. Methane parts per billion, 1900 parts per billion there. And nitrous oxide also parts per billion, 320 parts per billion there. It is from the fifth most recent IPCC assessment, the synthesis report, and I've simply updated it with the NOAA concentrations, which we've just seen. So this runs from 1750 to 2019. This shows that all three greenhouse gases are actually on an accelerating trend. In case of carbon dioxide, it's very obvious and very extreme, the steady acceleration. The acceleration is faster than ever over the past few years, as you can see there. Methane, if we look from 1750 up to 2019, and this is my dotted line, despite the fact that there was a plateau in the atmospheric concentration, which which the plateau which stopped, it kicked up again. Atmospheric methane started increasing again 2006, 2007. It's really on an accelerating long-term trend, and the current level is totally extreme. Nitrous oxide also very, very clearly on an accelerating trend from 1750. This acceleration has been faster than ever also over the past few years. I'm moving to these two data sets and projections on atmospheric carbon dioxide. What these two show is that fossil fuel CO2 emissions and atmospheric CO2 concentrations are both on the worst case scenario. This one here, this upper one, is atmospheric carbon dioxide concentration, the trace in blue from Scripps up to February 2019. This is emissions of fossil fuel carbon dioxide, and this is the trace from the Global Carbon Project that we've just seen. This runs from 2000 up to 2018. Atmospheric carbon dioxide concentrations, there's 400 parts per million. It's very obvious that atmospheric carbon dioxide concentration is accelerating right through from 1955 up to 2019. This trace here is from the Global Carbon Project, and I've compared this with the RCP scenarios from the last IPCC 2014 assessment. I've just taken the worst case scenario, which is the red one, the best case scenario, which is the blue one here. And what I was interested in is the question of whether, as a lot of people have been quite rightly thinking, that the CO2 emissions must be tracking the worst case scenario. So the worst case scenario is called RCP 8.5, and clearly those people are right. Emissions are tracking the worst case scenario, RCP 8.5. So this is absolutely terrible. We are on a globally suicidal course with respect to emissions, and also, of course, being reflected in the concentrations. Please note that this RCP 2.6 best case mitigation scenario, this is the only scenario that doesn't go above 2 degrees C by 2100, and it requires emissions to go into decline by 2020. This is from the synthesis report of the IPCC 2014 assessment. Now I'm moving to future greenhouse gas emissions, and this is crucially important. This is one of many scientific reports and intergovernmental reports. This one is from UNEP, the United Nations Environment Program. They do an annual gap report on emissions and emissions targets, and this one is the most recent one, 2018. This again is CO2 equivalent, so we're looking at carbon dioxide and methane and nitrous oxide, in other words. So the top plot here on the graph is what's called a reference scenario, and that's the scenario which is predicted without any policies. So this is the one which is the horrendous crime of all time, because these are the national emissions targets from all the world governments. They're filed with the United Nations. They are called INDCs. They're called Intended Nationally Determined Contributions. And they lead, as you can see, to a very substantial increase by 2030. Now, I've just told you that emissions, global emissions, must go into decline, and they must go into decline like now. And all of the research is agreed. All of these intergovernmental reports are agreed. They have for many years published charts, graphs, just like the one we're looking at now. It used to be for the 2 degrees C target. As you see, the newer one for the past couple of years that has been reported, because the scientists are now all behind the 1.5 degrees C report. This one, the emission, global emissions, the very latest they can go into decline is 2020. And they just decline more rapidly than the 2 degrees C. But note, both for the 2 degrees C, which is catastrophic target, and for 1.5 degrees C, emissions have to decline like now. We're in 2019. This is our absolute last chance. We're now going to look at the temperatures. We've left the temperature for later because the most important thing, of course, is the atmospheric greenhouse gases that determine the global surface warming. So I'm starting with the most recent authoritative record of global surface warming, which comes from the very important October 2018 IPCC 1.5 degrees C report. So this is the record from the IPCC 1.5 of the temperature increase. I've taken it from 1940, and you'll see the red line is the familiar global surface temperature change. Some ups and downs, but overall you can see that this is an accelerating rate of increase. If you take it from 1900, it's even more obvious, an accelerating rate of increase. This gold-colored line here is something that the scientists have been able to do over the past couple of years. It's called the Global Warming Index, the human-induced temperature, and that's the orange line, and that's just a straight acceleration. So what are these blue lines here? Well, they're very important. These blue lines, and these didn't get much attention at all, these are the model projections which were included. They're short-term model predictions, actually, which were included in the 1.5 degrees C report. And the model predictions show that it's going to continue accelerating. Now, it's bound to continue accelerating, so we will be at 1.5 degrees C by 2030, according to the models. This is the 2018 global warming record from NASA GISS, and it shows an accelerating trend, going up very rapidly in the past few years. This is a lowest smoothing. This is the standard application of the data by NASA GISS, and it's a smoothing just for 5 years. That is a very, very, very rapidly increasing global surface temperature. This record is taken from pre-industrial, being the average of 1881 to 1920. You can see the global average temperature increase is 1.1 degrees C. This is land warming. This is from another source. This is from Berkeley Earth. This is Professor Muller's team. And as you can see, the land is warming much, much faster than the land ocean. So land warming has reached up to 1.7 degrees C. There's no smoothing here. This is the annual record. This is also temperature increase from 1850, running from 1900 up to 2018. So I'm going to take a look at the Arctic now, and we're going to start here with Arctic warming. This shows Arctic warming in blue compared to global average warming in red. This record of Arctic warming is from the NOAA, from the most recent NOAA Arctic report card of 2018. And this shows very dramatically the acceleration of amplified Arctic warming. Arctic amplification is a well-known and extremely dangerous feedback effect in which the reduction of Arctic summer sea ice extent increases the warming by reducing the solar energy being reflected back into space, and the sea ice, as it melts back, being replaced by open Arctic ocean water, which is dark and which absorbs heat. So that's Arctic amplification. This record goes from 1960, and you can see the temperature increase of the Arctic is much higher than the global average. Blue is the Arctic warming, and red is the global average. These temperatures are from pre-industrial, and they run up to 3 degrees C here. To 2000, there's little difference between the global average warming and the Arctic warming. But subsequent to 2000, there's an increasing deviation of Arctic warming from global warming. As the summer sea ice melts back more and more, effect increases the Arctic warming more and more, called Arctic amplification. Here we see this absolutely huge difference of what amounts to 1 degree C difference. This is the big warming, the record warming, which happened in 2015-2016, with the El Nino boosting global warming even further. The difference persists up to the present time. The Arctic is warming now at more than double the global average, and there are regions in the Arctic which are already warming at 3 times the rate of the global average warming. We're now moving to permafrost warming, and the accelerating Arctic warming is causing accelerating permafrost warming. This is vitally, crucially important because, of course, permafrost contains a huge amount of, until very recently, safely frozen carbon. In fact, the Arctic contains double all the carbon in the atmosphere in permafrost. This is a recent, very important paper published this year in 2019. What the paper showed was that permafrost. I've taken 2 of the sites from the paper. This one in Alaska, right there, and this one in Siberia here. These are the images from the paper of the Arctic. There's Alaska here. So this is the Alaskan and Canadian Arctic, and here's Siberia, the vast region of Siberia, with the huge store of permafrost carbon. So here's Alaska then, and you can see this rapidly increasing. Yeah, I may be stretching it a little bit to say that this is accelerating, but it's close to it. And it's kicked up there and increasing over the past couple of years. But in Siberia, which is this brown one, it's quite obvious that this is accelerating, that the permafrost warming is accelerating. This is the combination of all the sites in the paper. This is temperature here on the left side on the vertical axis. This is temperature here also on the vertical axis. I've just taken this from 2008 up to 2016. So you can see that overall there is a definite acceleration of permafrost warming. We can now go over here, and this is also a finding on permafrost thawing, which was in the NOAA Arctic Report Card of 2016, and this wasn't picked up. And this is perhaps the most crucially important of the research finding on climate change of all. And it's the most important because the Arctic carbon sink has switched or is switching from a carbon sink to a carbon source. The quote from the NOAA is that thawing permafrost releases carbon into the atmosphere. Overall, tundra is presently releasing net carbon into the atmosphere. So this really is the Arctic carbon bomb. This is the planetary deadly permafrost carbon feedback. It has already been triggered. So this alone is a dire Earth emergency. This data set here shows the rapid decline of the Arctic sea ice. And these 2 data sets together show rapid decline and thinning of the Arctic sea ice. This top data set is from the NOAA again, the 2018 Arctic Report Card published in December. The record runs from 1978 up to 2018. This is simply the percentage difference in Arctic ice extent. So the black trace here is the March winter maximum when the sea ice is greatest in its extent, and the red is the Arctic summer in September sea ice minimum. Now you can see that both traces are declining. The summer sea ice a lot faster than the winter. But what's happening is that even in the wintertime, the extent is getting less and less and less. And that is important, that is significant. The summer sea ice pretty well crashes following 1995, and it has a very abrupt reduction in summer sea ice in 2007 and another abrupt reduction of the prevailing record low of 2012. This is, as I've explained, the feedback. This results in Arctic amplification, and it is also long been predicted to be a global warming feedback. If when all the Arctic summer sea ice is gone, and that's several million square miles of solar energy reflecting, when all that disappears and becomes open Arctic Ocean heat absorbing, it's predicted that this will have an amplification of global warming as well as of Arctic warming. So we're now going to take a look at what's happening to the volume or the thickness of the Arctic sea ice. So this upper blue trace is the maximum sea ice volume thickness. As you see, the research is new research published this year in 2019. So both the maximum volume thickness and the minimum volume thickness are declining steadily and very rapidly. We're moving now to the ice sheets. Greenland, of course, Arctic, but also the Antarctic ice sheet. So we're taking a look at the two ice sheets. And this is also a very recent research published in 2019. Both ice sheets are losing mass rapidly. They're melting away, and they're melting away fast. The Greenland ice sheet here, this is a satellite measurement uplift change, and in the case of the Antarctic research, it's the mass in gigaton of ice. There's the Greenland ice sheet, and as you can see from 2012, it has been declining precipitously. From 2008, there's an accelerating loss of Greenland ice mass. This particular stunning research suggests that Greenland may be at or very close to its tipping point, because when Greenland is melting from the top and from below. Warmer Atlantic water is eroding the sea ice from below. And also we know that there comes a time when the sheer weight of the sea ice with melting particularly below reaches a threshold at which time the Greenland is bound to slide ever so slowly down into the sea. This is a very, very slow long-term process, but as with pretty well everything on climate change, the research shows it's happening much faster than had previously been predicted. So here's the Antarctic ice sheet, this research 2019, and it's called 4 Decades of Antarctic Ice Sheet Mass Loss, etc. It showed that there was a much more rapid decline of lost ice sheet mass as had been previously predicted. Now there's research that came out a few years ago from satellite data which strongly suggested that the West Antarctic ice sheet had already exceeded its threshold and is past a tipping point for that much smaller aspect of the Antarctic ice sheet. But when the West Antarctic ice sheet disappears, that's going to have a further destabilizing effect on the huge mass of the Central Eastern Antarctic ice sheet. So obviously this 2019 research, these two research papers, portend a much faster sea level rise than had been previously predicted, and recent research shows that sea level rise is accelerating. And that brings me to the lower data sets, which is on the ocean. And this is 2018 research, climate change accelerating sea level rise, etc. And this is sea level rise in millimeters, and this runs from 1990 up to 2016, and very clear accelerating trend of sea level rise. Sea level rises because we get more ocean volume due first to the thermal expansion of the water, because most of the heat from added greenhouse gas emissions accumulating in the atmosphere, most of that heat goes to the oceans. And so the oceans have been very slowly increasing in volume. This is massive, though, because it's detectable by our instruments, by tide levels, and by satellite imaging. This paper and others explain that a lot more of the sea level rise is being contributed by more water coming from the melting of the ice sheets. That will continue. When we're looking at sea level rise from ice sheet melting, we're looking at a commitment for hundreds and hundreds of years of this situation persisting and getting increasingly worse. So I'm going to go to the ocean heat now, because we've just referred to that. And over 90% of the added greenhouse gas heat has gone to the oceans. This is another very recent research of 2019. It runs from 1950 up to 2016-17, showing accelerating ocean heating. This has been evident for a number of years from the NOAA ocean heat content site. So this runs from 1950 up to 2016-17. This green line included in the research is atmospheric CO2 concentration, which, as we've seen, is clearly accelerating, and 400 parts per million up to 420 parts per million there. This is the heat content in blue, this blue trace. On the right side of the graph is the ocean heat content. This is heat content measured by all the temperature recording buoys distributed all around the world's oceans. This goes down to 2,000 meters, so this is the deeper aspect of the heat that is being measured. Now, ocean heating is extremely bad for the oceans. Surface warming and ocean heat, of course, have practically terribly doomed the warm water coral reefs. But ocean heat also causes ocean deoxygenation, which you see here. This is a recent research paper, 2018, called Understanding and Challenges for Oceans in a Higher Carbon Dioxide World. And it had looked as though the large regions of ocean deoxygenation that have been expanding in all directions, this is deep open ocean deoxygenation. This isn't the deoxygenation that affects estuaries and coastlines from nitrogen pollution. This is due to atmospheric greenhouse gas cumulative heat in the lower atmosphere, most of which has gone to the oceans. It was very clear that the deoxygenation was progressing, and it looked like it might be accelerating like all the other data sets, but this research shows that it is. So we also have accelerating ocean deoxygenation. And, of course, life in the oceans requires oxygen as well as life on the land. So this is from the same research paper, so this is very up to date on ocean acidification. Now, we know for sure that ocean acidification has been accelerating. For example, this was published by a special research report by the World Meteorological Organization in 2015. This runs from 1960 up to the 2017. I've switched the graph record upside down. If you go to records of ocean acidification, what you'll find is ocean pH, which is water hydrogen ion potential. You won't see ocean acidification as such. Ocean acidification is inverse of the pH. So as pH goes down, ocean acidification goes up. So here I've reversed the pH, and this shows the increase, the relative increase in ocean acidification, and clearly shows that this is also accelerating. So finally we come to the conclusion, and the conclusion is a painful one, but it's totally definite from these multiple adverse data sets all going rapidly in the wrong direction, which shows that the world is trending to biosphere collapse. The adverse indicators continue to accelerate, including atmospheric carbon dioxide, ocean heat, global surface warming, sea level rise, and ocean acidification, and ocean deoxygenation. Ocean health is essential to land species survival. Carbon dioxide is on the worst case scenario, both for emissions and atmospheric concentrations. The national emissions targets of governments, the combined national targets, are a global death sentence of over 3 degrees C by 2100, which is over 4 degrees C by 2100, which is over 4 degrees C by 2300, but that is excluding feedback warming, and there will be extra feedback warming on top of that. The state of the Arctic, especially the carbon sink of the Arctic switching to source, presents a very high risk of multi-feedback runaway, called in the last published paper on this worst of all effects and complications of global warming, called hothouse Earth.